Anesthesiology has become a very safe area of medical care. It's been noted that anesthesiology is one of the few medical specialties where there's been a dramatic improvement in patient safety over the years. The old days where people used to die from anesthetics are gone, happily. Nowadays, the actual incidence of people dying secondary to anesthesia is extraordinarily rare. Every anesthetic machine, like a modern aircraft, has many. Nowadays, the actual incidence of people dying secondary to anesthesia is extraordinarily rare. Every anesthetic machine, like a modern aircraft, has many fail-safe devices attached to it. Included in these are the disconnect alarm, which alarms when it recognizes a decrease in system pressure, indicating the possibility of a system disconnect. In other words, the high-pressure gases that are entering the machine have somehow been cut off. Particularly if oxygen is cut off, this would mean that the major supply of oxygen to the machine was lost, and it's important that the machine lets you know when that happens. So there's a disconnect alarm. Vaporizer failures are almost unheard of nowadays because of the frequent checks that are done and recalibration that's done. And pressure limiters in the circuit prevent barotrauma or increased pressure damage to the lungs. High-pressure hoses, such as the supply hoses from the wall to the machine, are pin-indexed according to the gas they carry, so that they can only fit into certain connectors on the anesthetic machine, so that you don't have the risk of connecting an air hose or a nitrous oxide hose to the oxygen system in the machine. So in addition to the safety features I've already mentioned, all gas supplies that are connected to the anesthetic machine have agent-specific connectors. And vaporizers, which can run out of anesthetic liquid during an anesthetic and need to be refilled, can only be filled by the specific agent that they're designed to manage. The standing bellows in modern anesthetic machines minimizes the danger of incorrect gas flows. At one time, we had hanging bellows that could actually function in the absence of oxygen, and that was a major risk. Now they can't. Vaporizers that are positioned improperly, tilted, won't work. And pressure regulators in the machines are specific for each gas, reduce the gas pressure to an intermediate pressure within the machine, and then to a low pressure before gas gets to the patient. Pipeline and gas tank pressure gauges are prominently displayed on the machine within the view of the anesthesiologist. And in hospitals where there are big banks of gas cylinders or liquid oxygen containers, the equipment is checked daily. If there is an oxygen system failure, the machine continues to deliver air, which at least has 21% oxygen in it, to prevent hypoxemia. In other words, it's not really possible to inadvertently deliver 100% nitrous oxide, for instance, to a patient. And the oxygen flow meters are always positioned downstream from the nitrous oxide or airflow meters, so that a leak in a low-pressure system doesn't dilute the oxygen and result in a hypoxic breathing mixture. If there's a leak somewhere in the low-pressure system, the last thing that's affected is the oxygen, and the oxygen should be the dominant gas that's given to the patient even in that situation of a leak. The on-off knob on the oxygen flow meter is fluted and bigger than on the knobs in the nitrous oxide or airflow meters, so it's easy to feel even if you're not looking at it, although believe me, I'm not suggesting you don't look at it when you adjust it. The oxygen flow meter is made to disable the nitrous oxide flow meter if oxygen level is below 21%, or there's a failure in the oxygen system. So there's a continuous monitoring of inspired oxygen, and if it ever drops below 21% room air, the system automatically turns off any other gas that might be running, nitrous oxide or air. And a stiff button must be pushed on the vaporizer before vapor can be turned on. So there's either a catch that you compress with your fingers, or there's a button on the vaporizer dial that you have to push. And it's a bit of a push before you can turn it and change the vapor dose that you're providing. There's an interlock system which prevents more than one vaporizer from working at one time. So if you turn on the desflurane, you can't turn on the sevoflurane, and vice versa. And scavenging systems are set by international regulation, so we all have the same standards worldwide when it comes to scavenging systems. And an oxygen analyzer, low pressure analyzer, high pressure analyzer, and spirometer, which is a device for measuring breathing patterns, usually within the ventilator, are standard equipment on all anesthetic machines. So failure of anesthetic machines has become a very rare event. However, I'm aware of 2 events in my own hospital system in the last year that could have been disastrous. In one case, it was my own machine, and the entire breathing circuit and soda lime canister fell off the machine, landed on my foot, which was not a pleasant experience, but more importantly, left me with no way to ventilate the patient or deliver vapors to the patient. I was able to quickly change over to a bag and mask system and start a propofol infusion, so no damage to the patient occurred, but it was certainly a scary event. And there's been some changes to that machine to try to prevent it again in the future. On another machine, a brand new machine, the amount of desflurane set by the anesthesiologist was initially supplied properly by the machine, and then for some reason, suddenly it stopped providing the dose that had been set. There was a dramatic drop in the amount of desflurane, and only the fact that the anesthesiologist was paying attention saved the patient from waking up in the middle of surgery. Those machines are now being evaluated to determine if there's an underlying system problem that needs to be fixed.